In a classroom with 30 people, assume the birthdays are random amongst the 365 days. So we're equally likely, or each student is equally likely to be among any of the 365 days of the year. Find the probability that at least 2 people share a birthday. So the way I'm going to look at this, instead of thinking of birthdays, I'm going to say they're just choosing a number from 1 to 365. I think that's a little easier way to think about this, but hopefully you should see that it's the same question. It's still, 1 to 365 days. All right, so the first person chooses a number. There's no likelihood that they have the same number as somebody else. The second person chooses a number. They can choose from any of the 365 days, and there's a slight chance that they choose the same day, the same number as the first person. There's a 1 in 365 chance. For the next person, there would be then 2 days that have been chosen. So the problem with this sort of approach would then become, I don't know if the first 2 people chose the same day, the probability the third person chooses a day that's already been taken, would only be 1 out of 365. But if the first 2 people chose different days, there would now be a 2 out of 365 2 out of 365 chance that they choose a number that's already been taken. So rather than trying to approach it from that way, instead of saying the probability that at least 2 people share a birthday, I'm going to go ahead and call that my event E, and I'm going to instead think of this as E complement. This is everyone has a unique number. Sloppy writing. Okay, so thinking about this in terms of everyone having a unique birthday is actually going to be much cleaner than maybe the first 2 people sharing the birthday and then the third person having a 1 out of 365 chance, or if they're not sharing the birthday, it's a 2 out of 365. It's going to be much easier to say, okay, well, for the first person, there's a 365 out of 365 that there's a 100% chance that they choose a number that is not already taken. For the second person, this one of those numbers is now taken, so there's now 364 out of 365 that they choose a number that's not already taken. For the third person, it's going to be 363 out of 365, and so on. Now I'm multiplying these together, which does deserve a little bit of discussion. This is essentially the multiplication principle, it's the, what do you call it? The probability, it's conditional probabilities. The probability of E union F, no, E intersect F, what am I saying? Probability of E intersect F is equal to the probability of E times the probability of F given E. This is the multiplication that I'm using here. So I'm saying the first person, the probability that they choose a unique number is 365 out of 365. The second person, the probability they choose a unique number, given that the first person has chosen a number, is now 364 out of 365. This person, the probability they choose a unique number is 363 out of 365, given that everyone else previous to them has chosen a unique number, and so on. And this will continue until we have 30 terms. 30 factors, I guess. Now, a shorthand form of way of doing this, you'll notice the top parts are decreasing by 1 each, and there's going to be 30 of them. Well, 365 times 364 times ... and then ends up being 30 of them. Well, this is exactly what permutations do. So this would be 365 permute, NPR, 30. As far as the bottom is concerned, well, there's 30 of those, and this is much easier to compute. This is just 365 to the 30th. So this number right here, 365 permute 30 over 365 to the 30th, this will give us the probability we're looking for here. So parentheses, 365 NPR 30 divided by 365 to the 30th. I'm just putting these things in parentheses I mean, I don't think the parentheses are actually necessary now that I look at it, but I was just being a little careful there. There's actually a 29 or 0.2937. So the probability, this is the probability of E complement, remember? The probability that everyone chooses a unique birthday is 0.2937. So the probability that of E, the probability that at least 2 people share a birthday, is going to be 1 minus this number. 1 minus answer gives me 0.7063. So the probability that at least 2 people share a birthday is 70%. It's 0.7063.